this video, I try to solve this integral by using u substitution. Now, typically, whenever we look at this, we might think, well, what do you mean by u substitution? Shouldn't I just use trigonometric substitution? And the answer is yes, we can use trigonometric substitution, but on this one, I kind of want to use u sub without having to use trigonometric substitution. So, like, for example, let's say that I say that x is equal to 3 times u. So if that's the case, then that means that we have, let's see, if we differentiate, we have 3 du. So we actually don't have a 3 du. But what we can do next is this. We can actually just go ahead and divide by 3. Actually, that's okay. Yeah, 3 du is okay. So far everything looks good. So we're just going to go ahead and rewrite this as 2 divided by the square root of 9 minus, well, here you're going to get 9 u squared. But then note that du, or dx for that matter, is actually times 3 du. Now, rewriting this, we have basically, we have 6 times the integral of 1 over the square root of, now let's do this. Let's actually take out the 9. So we notice that we can take out the 9, which in this case leaves us with the square root of 9 multiplied by 1 minus u squared du. Now, of course, whenever we reduce this even further, you're going to notice that that's going to be 6 divided by 3 multiplied by the integral of 1 over the square root of 1 minus u squared du, finally giving us that we have 2 times the integral of 1 over 1 minus u squared. Now, there's a little trick that we're going to have to do here, though. Note that, for example, that when x is equal to 0, this tells me that u is equal to 0. But when x is equal to 3, using this equation over here, we get that u is equal to 1. So in actuality, we have that these limits of integration are from 0 to 1, 0 to 1, 0 to 1, and we have 0 to 1. Now, what that does to the integral is the following. Recall that basically that the derivative of sine inverse of u is equal to 1 divided by the square root of 1 minus u squared times du dx. So essentially, my thing was that I just needed to rewrite the integral in a way that I can just say, okay, that's just inverse sine. So, okay, well, that gives us 2 times, apparently it's just sine inverse of u from 0 to 1, which if we do this, we have 2 sine inverse of 1 minus 2 sine inverse of 0. But sine inverse of 1 is pi over 2, so we get 2 times pi over 2, which apparently is just equal to pi. So we have that the answer actually is just pi. Now, note that, for example, that another way that we could have another way that we could have worked this problem, for instance, is that what if we were to use that 1 divided by the square root of a squared minus x squared dx is simply just going to be sine inverse of x over a, and then we have plus c. The only thing, though, is that it hasn't been established whether or not, this is true, but it can be proven whether you differentiate the right-hand side or if you work it the exact same way. Because, for example, we can essentially say the exact same thing where in this case, let's go ahead and just rewrite it as we have 1 divided by the square root of a squared is a, and then we have 1 minus x squared over a squared. In this case, you would say that u is x over a, and then that du is dx over a. From there, that's where you would basically just say that, okay, well, just multiply by a on both sides. And when you rewrite this integral, you have the integral of, and let's put a dx there because I forgot it. You have a du divided by a, and then you have the square root of, note that that's just going to be 1 minus u squared, which in this case is just the integral of du over the square root of 1 minus u squared, which in fact is sine inverse of u plus c um, plus c, and then that's going to be sine inverse of x over a plus c. How does this help you though? This helps you in the aspect that, if you were integrating your original problem from 0 to 3, and then you had the square root of 1, well, in this case, 9 minus x squared dx, well, you would have used this identity where you would say sine inverse of x over 3, because in this case it matches the format, okay, that you can just say that it's just sine inverse x over 3 from 0 to 3, which is in fact kind of like the same thing, except ours was it had a 2. So if you want to put a 2 out here so that way we're consistent, you would just say, okay, well, that's just going to be 2 times sine inverse of 1 minus 2 sine inverse of 0, and it gives you exactly the same thing, which is still pi. Okay, how this differentiates from, you using trigonometric substitution is that in using trigonometric substitution, that's where, your whole integral from 0 to 3 of 2 divided by the square root of 1 minus, and I keep doing 1 minus, but 9 minus x squared. The difference is that here you would have to realize that, yeah, that 3 sine theta equals to your u. And then from there, that's where you would have that 3 cosine theta d theta equals to du. Now, from there, you would probably just say that, well, 3 cosine theta is equal to 9 minus x squared. Then from there, you would probably go about plugging things in, and you would say, okay, well, I have 2 divided by 3 cosine theta, but I have that I'm multiplying that by 3 cosine theta d theta. But then from there, you have that the limits of integration. Well, if you plug in, well, I think I might have used x's. Yeah, let me just go ahead and change that really quick. Okay, so yeah, let me just change that to an x, and let me just change that to an x. Okay, so when x is 0, then that means that theta is 0. When x is 3, you get that theta is pi over 2. So in that case, you end up with the integral from 0 to pi over 2 of 2 times d theta, which is equal to 2 times theta from 0 to pi over 2, which is equal to 2 times pi over 2, which is equal to still pi. So you can see that, all three methods essentially give you the exact same thing. But, when it comes to being given a question on your exam that is very specific to the method that you're supposed to use, which in this case, we want to try to solve this using a u substitution. Note that, we still were able to solve it even without using trigonometric substitution and things like that, or without using that we knew a formula in this case, or without using that, okay, yeah, we can implement a trigonometric substitution and then still get the same thing. So with that, it's important that you kind of solve the problem with respect to how it's being phrased or asked, so that way, you get full credit on your test problems and things like that.